Yeah, good day. Welcome back today to my Campus Guide channel. Today we are considering another circuit analysis, and please make sure you subscribe so that you can get our daily updates. So today we are looking at Thevenin's theory, how to use Thevenin's theory to solve electrical circuit problems. So let's start. Thevenin's deals with some procedures, but before we start procedures, we have to know some terms that comes in place when we are talking about Thevenin's. The first term that we come across is VTH, which is Thevenin's voltage. Is the voltage seen in between the open circuit terminals. Is the voltage seen in between the open circuit terminals. And another term that we come across is RTH. And RTH is the resistance of the circuit when all voltage sources are being deactivated, and only VTH is acting alone. Is the resistance seen when all voltage sources are being deactivated and only VTH acts alone. So let's look at some procedures that Thevenin's used in his analysis. The first point we have to know is we have to remove the resistor in question from the circuit and mark the two terminals. So in the circuit or in the program, we'll be given a resistor which is in question. So that resistor in question, you have to remove it in the first place and make that point an open circuit. Then you mark the two terminals of the open circuit. That is the first point you have to know. The second point is to find the short circuit voltage or the open circuit voltage. So the open circuit voltage, you have to find the voltage across that open circuit, which is the VTH, using Kirchhoff voltage law. Then the next step is to deactivate all sources and allow VTH to act alone. Deactivate all voltage sources and allow VTH to act alone. Then the next step is to find the total resistance, that is our RTH of the circuit, when VTH is acting alone. Then the third point is to reproduce Thevenin's equivalent circuits and connect the resistors whose current is to be found, and connect the resistor whose current is to be found. This resistor is the resistor in question. Then, after that, calculate the current in the steps. In step 5, this current is being sought for. So let's take a similar problem and know how best we can resolve it. Now, we have a circuit here, and the question is, using Thevenin's theorem, determine the current in the 3 ohm resistor of the circuit below. So we are to determine the current that will flow through this resistor, which is 3 ohm. So right now we have to apply our first and second law in analyzing this circuit, which is to remove this resistor in question and mark the two terminals A and B and replace it with what? Thevenin's voltage. So once we are done with that, the second step is to find the magnitude of the voltage across this open circuit, and the magnitude of the voltage across this open circuit will be equal to the voltage around this point, which is our VTH. So now let's do that. So I'm labeling my diagram. So because of I'm going to consider this circuit loop after loop. So I have A, B, C, D, E, F as the terminals or the markings of my circuit. Once I'm done with that, now I need to find the voltage, which is our VTH. And VTH can only be found using what? Kirchhoff voltage law. So we are going to consider this circuit loop after loop so that we can find our VTH here. So the first point is I want to find the voltage around this point. So I'll write an equation for this point. So taking the loop DCBET, I'm taking this loop DCBET. So we are considering this loop, and we have 35 volts plus our VTH should be equal to 6, and the current which is here, I've labeled it I because we don't know the magnitude. So we are considering voltage law. It says the sum of voltage is equal to the voltage in the circuit. So taking this loop, we have 35 and another voltage here, which is our VTH. When you add them, it should be equal to the resistor there times the current which is flowing through this loop. So I label it my equation 1. Then I consider the second loop, which is the loop FABEF. That is this loop. I'm considering this loop. So my 42 volts will be equal to 12 plus 6. We have 12 as a resistor here and 6 as resistor here times the current which will be flowing through them. Know that the same current will flow through them. So from this point, I can find my I, which is the current, by making I the subject here. So my I will be equal to 2.33 ampere. So now I can substitute this I into this equation to find my VTH. So once I'm done with that, I can find the value of my VTH to be minus 21 volts. Minus 21 volts. So that will be the voltage that will be seen across the open circuit terminals. So once I have found my VTH, I'll have to move on to step 3 and 4. Step 3 and 4. It says we have to deactivate all voltage sources and allow VTH to act alone. Then we find the resistance, which is our outage. So I'll do that. You see all voltage sources have been deactivated, and now we need to find our outage. So outage is the resistance seen when all voltage sources are being deactivated. So from here I can see that this 12 ohm is parallel to what? This is ohm. So we take their product and divide by their sum. So I can see when all sources are being deactivated, our outage value is 4 ohm. It's 4 ohm. So once we are done with that, I'll move on to step 5 and 6. Step 5 is saying we should draw Thevenin's equivalent circuit. And then, so this Thevenin's equivalent circuit is just a simple circuit where the voltage source is now our VTH, which is minus 21 volts, which is connected to the RTH, which is 4 ohm, and this resistor that we need to find, which was removed at the initial point, will also be connected at the terminals A, B, which is 3 ohm. So now we are going to use Thevenin's equivalent. Thevenin's produced an equation or a formula for finding the current that will flow through this 3 ohm. It states Thevenin's current that will flow through the 3 ohm will be equal to the Thevenin's voltage divided by the Thevenin's resistance plus the resistor that is in question. So we have 21 divided by 4 plus 3, which is equal to minus 3 ampere. So 3 ampere will be the current that will flow through this 3 ohm resistor. Why are we getting negative? Someone may ask. It's because the direction that we choose for our VTH, it doesn't matter. That means the current will be flowing through the opposite direction.